After you import your data, but before you run your hypothesis tests, you should explore your data. When you have categorical variables, you want to know if you have any missing data. You want to see frequencies, percentages, and get a picture of how those data look. We are going to dive deeper into exploring and summarizing categorical data with SPSS. In the history of statistics, we learned that there are 4 levels of measurement: nominal, ordinal, interval, and ratio. You are already familiar with the icons that IBM SPSS statistics software uses to indicate the levels of measurement, such as the 3 dots for nominal, the 3 bars for ordinal, and the ruler for scale variables. Although we can distinguish between interval and ratio data, we don't need to for most purposes. So SPSS treats interval and ratio data as the same, and it calls them scale level data. You may not be familiar with less commonly used icons, such as the small a in a circle to indicate a string variable for either ordered or unordered categories. If you have set your variable to be a date, you will see the calendar added to the variable measure. And if you are using a time measure, you will see the clock. Now that looks like a lot of options, and it is. So how can we simplify this complexity to the fundamental differences that we need to understand? Here is how to think about variables. As you are learning or exploring a variable, begin by asking whether it is creating a category or whether it is measuring something. Nominal and ordinal data create categories. Scale data measure something. Let's practice by exploring a dataset that you are not yet familiar with. This is the demo.sav dataset supplied by IBM with your IBM SPSS statistics software. If you need help finding and opening this dataset, you can follow the links in the description for a video about where to find it and how to open it. In Variable View, we see the variable names, labels, and levels of measurement. Let's see what we have. Age in years. Is time a category, or is it measuring something? It is measuring something. Your actual age rounded down in years. Years is a continuous measurement, and it is scale. What about marital status? Married versus unmarried. Are those categories or measurements? Marital status is a category. Are you in the category of people who are married or in the category of people who are not married? We are not measuring how married you are, just which category you fit in. What are other categories? Here we have income measured in thousands. But this is income category. Any guess to which of these variables is the categorical variable? It is, of course, income category. The raw data were exactly the same, but in one case, we have a measurement of income in thousands, and in another case, we have the same income data organized into bands or categories of income. Are you retired? That is a category. Yes or no? How many years have you been with your current employer? That is measuring something. Years. Job satisfaction might be measuring something if it's from a validated tool like the Job Satisfaction Survey. But when we look closer, we see that it is actually 5 categories from highly satisfied to highly dissatisfied. So it is really categorical. How many people you live with is a number, so it's measuring something. Whether or not you have voicemail, call waiting, own a TV, or a VCR, or a PDA. Those are all categories of yes and no. As you can see, the first step of data exploration is to make sure that the levels are correctly set. In this case, much of the categorical data has been misidentified as scaled. We can change those. Categorical variables have a limited number of distinct categories. So for example, gender, race, type of diagnosis, type of religion, or political party affiliation. Categorical variables can be numeric, such as coding 0 for unmarried and 1 for married. Or they can be string data, such as coding M for male and F for female. Categorical data are also referred to as qualitative data. Once you have your categorical variables, you should then consider whether those categories are ordered or unordered. Now, some categories do not have an inherent order, or they are all at the same level. So for instance, if you were on the red team or the blue team, you were assigned to the experimental or the control group. You are married or single, male, female, racial categories, received drug A or drug B. These are all examples of unordered groups. So for unordered categories, we want to know 1, what are the categories? And 2, how many people are in each category? This is all nominal data. Now, other categories have an underlying order or a meaningful ranking. So for example, freshmen are earlier in their academic career than seniors. Job experience could include apprentice, journeyman, and master. Academics can be tenured, associate professor, full professor. Job skill can be identified as low, medium, or high. Drug dosage could be low, medium, or high. Symptoms could be mild, moderate, or severe. Data at this level are placed in some order. Most often, this order is a ranking of the data from highest to lowest, best to worst. But the distance between the values cannot be calculated. This is ordinal data. For categorical data, the most typical summary measure is the number or percentage of cases in each category. For the unordered categories, or the nominal data, use the mode as your measure of central tendency, and the range if you need a measure of variability. Use a bar chart for a graph. For the ordered categories, or the ordinal data, you can use the mode if the number of categories is small, say up to 5. You could use the median, the value at which half of the cases fall above or below, if there are a large number of ordered categories. Ordinal data may be displayed with a bar chart or with a histogram. All of these are nominal data. Do you belong in the category of I own a PDA or do you not? So as you've probably figured out, this is an old data set. I like to think of it as retro data. People were asked whether they own a VCR, own a CD player, or a PDA. I love it. In case you're too young to remember, long before we had these, we used to keep track of our calendars on one of these, a personal digital assistant. And instead of text messages, we had pagers and fax machines. And we got our news from newspapers. And we liked it. Let's analyze these data. Go to Analyze, Descriptive Statistics, Frequencies. Drag all 3 of these variables into the variables box and click OK. We see a frequency table for each variable. The frequency table reveals that only 20.4% of people own a PDA, but almost everyone owns a VCR and a CD player. If we were doing a similar study today, we might ask how many people own a smartphone or how many own a 3D printer. Let's dive deeper. Click on the Dialog Recall button to bring up the Frequencies dialog box again. We need some charts. Click on Charts. Charts for nominal categorical data could be a bar graph or a pie chart. Although if you use pie charts, people will laugh at you for not knowing that pie charts are a horrible way to display data, so please don't use pie charts. Instead, select bar charts. We use a bar chart for nominal data because the categories are disconnected, just like the bars in a bar chart do not touch. Think of a bar chart and prison bars. The bars have a gap in between. If the bars touch, then that would be a histogram. Let's also get some statistics, although this is typically not necessary. Let's get the mode, the minimum, and the maximum. Click Continue, and then OK. In the output window, we can check to see if we have missing values and how many. This is a nice clean data set, so there are no missing values. We see the frequency tables for each variable, and we see the bar chart for each of our variables. The taller the bars, the more people own a VCR or a CD player, and not many people own a PDA. It's too bad. So what do I mean that the data response options are disconnected? Consider that if we were to switch the yes and no columns in a bar chart, we would still get exactly the same information from the bar chart. Now let's explore our ordered categorical variables, or our ordinal data. Click on the Dialog Recall button to bring up the Frequencies dialog box again. Clear the previous analysis by clicking Reset. Now, move over some ordinal variables, like income category, primary vehicle price category, and job satisfaction, which is labeled as scale, but we actually know it's an ordered category. For the statistics, get the median, and also the minimum and maximum. Click Continue. For charts, we will use a histogram. But these are categorical data, so we do not need the normal curve. Click Continue. Format is where we could sort the values ascending or descending, by values or by counts. We will leave the settings sorted by ascending values. The settings for style can also be left at their default settings. Click OK. Notice how some of the income categories are ordered categories, and they need to stay in the correct order. It would not make sense to arrange them in order of magnitude. Job satisfaction should be ordered from least to greatest. But notice how the vehicle price is economy, standard, luxury. I would treat those as three categories without ordering them. As you can see, when you examine the data, you may make different choices about how you ultimately want to display them. You can use these same techniques with scale level data if you want to. Use the menu recall to bring back the frequencies command box. I want to show you both income and income category. Move over income. I would like to have these variables next to each other, but income category is at the top. No problem. I can drag it and drop it down below. Now click OK. Now here we have this huge, unmanageable frequency table, which is why I don't use frequency tables with scale data, only categorical data. Keep scrolling, keep scrolling. Notice two very different pictures when we get from the income categories to the actual income. This is an important point. The picture that we get from the actual data shows us the distribution. That distribution can be altered, sometimes by nefarious characters trying to mislead us with statistics, by skillfully manipulating the size of the bars and the category bands. Always honestly display your data. And here's one more thing. We can also use categorical variables along with scale level variables. So for instance, we could create a bar chart for average